class. This is the first part of, this is the first part of 19A problems. So let's get started. I put a timer on for 6 minutes, so as far as we make it at 6 minutes, that's where we're going to go to. Which of the following processes are spontaneous? That means it happens without outside intervention. We try not to be too technical about this. It's difficult to know where to stop. I've talked with some students about this. I think they bring a very valid point about spreading the fragrance of perfume through a room. Does that mean like without outside intervention? That means that you open the bottle of perfume and put the bottle down and then let it naturally, the fragrance spread on its own. That just opening the bottle is not considered part of the experiment. It's only after the bottle has been opened and it's the gas molecules are free to roam the room. So this would be spontaneous. This would be spontaneous because opening up the bottle is not considered to be outside intervention. So separating a mixture of N2 and O2 into two separate samples, one that is pure nitrogen and the other one that is pure O2, besides being almost impossible to do because you'd have to separate the molecules of N2 and O2, which is really, really difficult to do unless you're using some kind of very exact filter or some process that only latches onto one of the molecules. But you got to be careful because if we're talking about separating a mixture that is physical, so you wouldn't want to use a chemical process with this. It doesn't matter because this would be considered non-spontaneous. You are not able to separate mixtures without outside intervention. You would have to do it some way. Like separating sand and salt, you would have to, move the salt to one side and the sand to the other side with a very exacting, like pinchers or whatever, doesn't matter. Bursting of an inflatable balloon. This one's a little bit more difficult to understand. This one's a little bit more complex because at some point, if you leave a balloon in a room, a rubber balloon, eventually the rubber will fail and the balloon will then deflate or burst, but usually it takes outside intervention to do it before the rubber, failing on its own. So I would say this is also a non-spontaneous situation. But I understand the argument for saying that it could be spontaneous, just taking a long time to happen. Reaction of sodium metal with chlorine gas to form sodium chloride. Well, I actually have a picture of this. It's in chapter 8. It's this one where it says the formation of sodium chloride, where we're exchanging electrons from sodium to chlorine. And when that happens, we have this reaction. This reaction actually happens spontaneously. This is something we only have to put these two together. Once we put them together, then it automatically happens. That's because when you put two things together and they form bonds, energy is given off. But breaking bonds takes in energy. So forming bonds breaks energy, gives energy off. So that's typically a spontaneous procedure. So there's one more here then for letter E. The dissolution, do not be confused by this term. This just means dissolve. So the dissolution of HCl, HCl, that looks like an I, it's not. HCl gas in water to form concentrated hydrochloric acid. This would be something, now you set up the whole apparatus and you allow the gas to bubble through the water, and naturally this dissolves into the water on its own. So this would be considered spontaneous because once you set the operation up, once you set everything up and then it goes forward and bubbles HCl through the water, the fact that it forms concentrated hydrochloric acid happens spontaneously on its own. I just want to make sure we're clear because of the difference between, of course, if you have to set the apparatus up, that is outside intervention, but we are talking about after the process has started where the HCl has bubbled through the water. Okay, moving on. Let's go on to Problem number 12, normal freezing point of 1-propanol is a negative 127 degrees Celsius. Is the freezing of 1-propanol endothermic or exothermic? So if we are freezing, that means that we have an amount of our 1-propanol like this, and it's a liquid. You can see the wavy lines. That means liquid. So if it's a liquid like this, for it to turn into a block of 1-propanol, that means heat has to leave the system like this, and if heat is leaving the system, that is exothermic. Freezing is an exothermic process. I know that kind of screws you up, but if we are going down, I know it's against what you think, but that means that, like, if I have 1-propanol vapor and it's condensing here, that means that it is losing heat and organizing. The molecules are organizing. That means that the system is losing heat, and that's exothermic always. Okay. However, if we're melting, that's it. I'll pick this up at the end. Let me turn the timer off. I'll answer A and B, and then we'll start up with 12, C, and D then. So freezing is exothermic, melting and boiling in this direction are endothermic. The systems are gaining heat. So in what temperature range is the freezing of 1-propanol a spontaneous process? Well, that's easy. Anything greater than negative 127 degrees Celsius means that it is a spontaneous procedure, because it's actually pulling in. Yeah, you're right. If you're thinking, no, I don't think so, I think he's wrong, you are right. I'm talking about freezing. Freezing means less than negative 127. It would happen spontaneously. Sorry about that. Okay, on to the next part.